Good morning, everybody. I hope that we're having a great day and a great week so far. Today's video is going to be all about functions. What are they? How can we determine if something is a function? And we'll talk all about that. So, without further ado, let's get to the video.
Today's video is going to be all about functions, and by the end of this video, I hope that you're able to determine whether a relation is a function, and I hope that you're able to find function values. But let's start off with some vocabulary. So a function is a relationship that pairs each input value with exactly one output value. An input value can be thought of as x, and our output can be thought of as y. So for every input, there is one output. In a relationship between variables, the dependent variable changes in response to the independent variable. The vertical line test is a test to see if the graph represents a function. If the vertical line test intersects the graph more than once, it fails the test and is not considered a function. Equations that are functions can be written in a form called function notation, and it is used to find the element in the range that will correspond the elements in the domain. And we can see in the bottom there they have our different kinds, our equation versus function notation. Really our main difference is that instead of y, we change it to f of x. It essentially represents the same thing. And the thing that's really important for us to remember when it comes to functions is we can think about them like a vending machine, right? If I were to input a code, I am going to get exactly one item out of the vending machine. It would not be a function if I were to input one code and I could get 5 things out of the vending machine. That would be an example of not a function. So let's put these ideas to the test and try to figure out what is a function and what is not. So 1a, determine whether each relation is a function. The main thing that I'm going to look for when I'm working with these is I'm going to look at my inputs. I'm going to make sure that every single input has exactly one output. And in this case, it does. I am not repeating an input. So in this case, I can see that yes, this is a function. And remember, I can think of input as x and output as y. Let's look at part B. If I look at part B, I look at my inputs here and they are all the same. And in fact, every input that I have has a different output. So this is really saying my one input could have several different outputs, which is exactly not a function. So no, this is not considered a function. Let's go down to example 2. Use the vertical line test. Which graph represents a function? So all I have to do is I need to draw vertical lines through this, and I can draw a vertical line here, here, or here, and I can see that it's still going to intersect in more than one spot. So that is not a function. Whereas if I draw a vertical line anywhere on that graph, I can see I only intersect in one spot. So yes, B is a function. C is going to be a little different because it looks like it's a function if I draw a line right there or right there. But if I were to draw a line right here in the center, I see that it's going to intersect in 2 spots, making it not a function. So it is important to make sure that we try to do several lines for our vertical line test. Let's move on to some other questions. Evaluate each function for the given value. So I have f of x equals negative 2x plus 11, and I need to solve that for f of 5, f of negative 3, and 3 minus f of 0. And what's really nice about these is that I can just swap out my x value for whatever number that they're putting in. So I know that f of 5 is really equal to negative 2 times 5 plus 11, which is going to equal negative 10 plus 11, which is going to equal 1. If I do f of negative 3, the same thing happens. So I do negative 2 times negative 3. Oops, let me change that to be a negative 3 plus 11. So I have 6 plus 11, which is going to give me 17. And in this last section, I need to figure out what f of 0 is, find out what that value is. So I do negative 2 times 0 plus 11. So that's just going to give me 11. But now I need to do 3 minus 11. and that's going to give me -8. And the same thing happens for part B. I need to take the value that they have in for x and plug that in and see what output I get. Now, for our last question, write a function rule to model the cost per month of a cell phone data plan, then evaluate the function for a given number of data. So I see that my monthly service fee is $24.99, and my rate per gigabyte of data is $5. So I see that that is going to be my variable cost. That is my rate of change. So I see here that it's going to be 5 times the number of months, and it's always going to be $24.99 every month, no matter what. So I can make my cost, I can make it C of x equals 5 times the number of months plus $24.99. Okay? Now, all I need to do is, if I were to try to do C of 13 to try to figure out how much money I would use, I would plug in 13 for x plus $24.99. And I would ultimately find that it's going to be $89.99. And those are all of the questions that I have. So I'm going to go back to our vocabulary here. Main thing about functions is that every single input has exactly one output, and we could do the vertical line test as well to determine whether or not a graph is a function. If you have other questions, feel free to message me on Schoology. You know how to reach me. But this is all that I have for now. So I hope that you have a great rest of your day and a great week.